Unit 3, Lesson 2, Ready, Set, Go. Well, we assigned just the problems number 1 and 2 from the Ready section. You have 2 lines, and you're trying to find the point of intersection. Now, most students in class worked on this using Desmos.com, and you can certainly do that for yourself right now. Just skip this part of the video. But I'm going to show you how to do it by hand without technology. So the first function has a -7 at the end. I'm going to go down on the y-axis to -7. 1, 2, 3, 4, 5, 6, 7. The very bottom. Now the slope is the number in front of x, 2. So I'm going to go up 2 and over 1 as a staircase over and over again, as many times as I need to get to the other edge of the graph. There's where my line goes through. Now the other line has a +5 at the end. That's where I go on the y-axis. 1, 2, 3, 4, 5 from the origin puts me right about here. And now the slope is -4. That means -4 over 1. So from there, I go down 4, 1, 2, 3, 4, and over 1. Down 1, 2, 3, 4, and over 1. There's my point of intersection. So at 2, -3. Let's do one more. Number 2, f of x starts at -2 on the y-axis. And the slope is -5. So that means I go from there down 5, 1, 2, 3, 4, 5, over 1. Since that's all I can do in that direction, I'm going to go the other direction. I'm going to go up 5, 1, 2, 3, 4, 5, and left 1. That gives me another point that's on the line. So the line goes through here. Then for my other line, it starts at +1 on the y-axis, and it has a slope of -2. So that's -2 over 1. If I go down 2 and over 1, and then down 2 and over 1, okay, I'm making the line. I'm getting farther from the point of intersection. So I need to go back the other way. I need to go up 2 and left 1, and there's my point of intersection at -1, 3. Let's do a few more, finish out the line. Okay, so these are very close together, but we have our point of intersection. Right here at -1, 3. Now we're going to go down to the graphs in the set section. Now notice there's a number of things we're going to do for each graph. We're going to state where it's increasing, where it's decreasing. We're going to write the minimum or the maximum. We're going to write the domain, we're going to write the range, and we're going to answer the question that's underneath the graph. So let's do intervals of increase. Well, imagine you're driving a little car on this hill, and you're going to be going uphill from 0 on the x to 5 on the x. So that would be our increase from 0 to 5. Our decrease, if we just keep writing it, I'm going to change color. And now we're going downhill, downhill. So in the x from 5 to 20 is our interval of decrease. Okay, next, let's describe where the maximum is. The maximum is this point up here at the top. That's 511. Where's the minimum? There's 2 points that are the minimum, down here and down here. So that would be the points 0, 2, and 22. And domain and range. So the domain, where am I allowed to be in the x-axis? Anywhere from 0 to 20. Range, where am I allowed to be in the y direction? Anywhere from 2, here again, 2 up to 11. The range all goes from 2 to 11. Now, the question at the bottom, what is the highest altitude reached during the trip? Okay, notice this. At the top of the graph, it says altitude in thousands of feet. So these numbers on the y-axis, they are actually times 1,000. So since our highest point was 11, right, on our maximum you can see 11, on our range you can see 11. But that means 11,000 feet. So it's definitely a mountain. This is some sort of a mountain climb. Or it could be an airplane. So something similar like that for problem number 8. Problem number 9. So if you need to know what the answers of those are, please look them up on the Canvas module. We'll look real briefly here at number 10. It says, considering the table of values that represent a continuous function, which models the amount of water in the tank that supplies drinking water to a town. Based on the information in the table, determine the desired intervals and answer the questions. So increasing, again, what you would do is you would look for, 24 to 28, 28 to 30. Oh, then I went down to 22. So it only increased from 0 to 2. But I need to look at the rest of the story. It goes decrease, decrease, decrease. And then there's an increase again. So 15 up to 18, 18 to 21, 21 to 25. So it also increased from 5 on the x to 8 on the x. Oops, let's write that better. 5 to 8. Oh, that actually will go, okay, now decrease would go from 30 down to 18. 18, because 15 increases to 18. So 30 to, let's see, on the x-axis, that would be from 2 until I get down to 5. The maximum looks like it's 30. So 230. The minimum is, I'd say 15. So 515. The domain x is allowed to be anywhere from 0 to 8. Part F, are you completely certain that your responses above would be the actual values for the water level? And if so, why? And if not, why not? No, since the table of values are snapshots in time and a discrete data set, we don't know what the continuous function related to water level is doing between each hour measurement. So that means that, for example, it could have had a maximum more than 30 because 30 happens somewhere between hour 1 and hour 3. But there could have been a time when it actually went above 30 and it just came down in time for measuring. So the simple answer to that is no, and the reason would be these are discrete values in the table, but it's a continuous function. Well, that's it for this assignment. See you in the future.